Hi, welcome to this talk. I'm Philipp Langer. I'm a software architect at Eclipse Source, which is a company that provides technologies and services for building custom tools and IDEs together with our customers. And today I'm excited to talk about how to build diagram editors for cloud IDEs with Eclipse GLSP. So let's dive in. Eclipse GLSP is a short for Graphical Language Server Platform. It's an open source project at the Eclipse Foundation and essentially provides a client-server framework for building diagram editors like the ones that we see here on this slide. For instance, a UML class diagram, function block diagram, equa diagram, or whatever diagram type you want to integrate in your cloud IDE. GLSP editors can then very easily be integrated into any web applications, essentially, but also into cloud IDEs such as Eclipse Theia or VS Code. So basically, the fundamental idea behind GLSP is to apply the architectural pattern of the language server protocol, which is hugely popular for programming languages, to graphical modeling. So basically with that, it allows to unlock the same benefits as LSP does, which is it enables the development of browser-based diagram clients, whereas the front end is really focused on rendering and user interaction, and all the heavy lifting and the language smarts is encapsulated in a diagram server component. The GLSP project is, as I said, open source at the Eclipse Foundation. You can find it on GitHub under this URL. Please feel free to check it out. So basically what this project provides is 4 types of components. First of all, it provides server frameworks that allow you to build specific diagram servers for your diagram language efficiently. GLSP provides 2 server frameworks for that. One is based on Java, if you prefer that, or one is based on Node.js, so that you can also use TypeScript to develop your diagram servers. Aside from that, it provides a protocol specification that defines the messages that can be sent back and forth between client and server, which is extensible to add custom messages if you need. Then it provides a client framework based on TypeScript that is basically a framework for defining how you render certain diagrams onto your in your diagram editor, and how you build the user interface and interaction with the user in that framework. Once you have done that and built a server and a client framework, you can then use one of the platform integrations that are provided by the project to integrate your diagram editor natively into any of the aforementioned options like Eclipse Theia, VS Code, or even Eclipse RCP if you still want to support that platform. So how does GLSP work? So whenever a user, for instance, opens a file in let's say, Eclipse Theia, then the Theia integration of GLSP will trigger the GLSP diagram editor for your language, and this will then send an initialization request with certain parameters like a URI that identifies the file, or a diagram type, or any arbitrary custom arguments from the client to the server. The server will then be initialized, and based on those parameters that you've sent, has the responsibility to load the actual source model. The source model is essentially the actual data source that contains the information that you need to actually show a diagram, and the server needs to be able to load that. This source model can essentially have any format or based on any modeling framework, so GLSP does not put any restrictions on that. Typical choices are models based on the Eclipse modeling framework, but also arbitrary JSON formats, even Xtext-based models or databases, or model servers such as the one provided by EMF Cloud project. Once the model is then loaded, the server will then transform that based on the model into a so-called graph model that essentially describes what is to be shown on the diagram. The graph model is sort of like a JSON-based description that is containing typed nodes and edges, which exactly specifies structurally what is to be shown on the in the diagram editor. This graph model is then sent from the server to the client, and the client will then map this graph model elements onto SVG so that it can actually then render it in the diagram editor and show the diagram graphically. On top of that, once this is done, there are generic editing tools that you can apply, for instance, to create edges, to move nodes, resize them, and so on. So this client rendering part is heavily based on Eclipse Sprody, which is a really cool SVG framework, also hosted at the Eclipse Foundation. So you should really check that out. It's amazingly flexible when it comes to rendering, and that's also good for any GLSP-based diagram editor, of course. The whole communication between the client and the server is based on an action protocol that is defined in the GLSP protocol. And of course, this is also extensible in many ways so that you can add custom handlers and custom actions to client or server. By default, the protocol defines different types of actions to cover different concerns. So for instance, for the client to request which palette actions actually or which operations can actually be applied in a certain context. When then the client would apply such an operation, there is a specific action type to request the application of this operation so that the server can then modify the source model, regenerate the graph, essentially the same step as we did before, and then send with a graph update action or model update action, as it is called, back to the client to re-render that. And for all the other features like validation, resolving navigation targets, and so on, there is specific actions so that client and server can exchange this information accordingly. All right, enough with this theory. Let's have a look at a demo. So let me just bring up an example diagram editor that we see here inside of an Eclipse Theia Cloud IDE. So basically that's Eclipse Theia, where a diagram editor based on GLSP is registered for WF files. So whenever I click that, you see that the diagram editor will open, showing a certain diagram. So basically, this diagram editor that has been brought up did everything that we just discussed before. So it sent an initialization request. The server then loaded, in this case, a JSON file, transformed that into a graph model, sent it back to the client, which then transformed it into SVG based on Eclipse Sprody until it eventually renders. What it also did is it requested the palette items that we see here on the right-hand side so that the client knows what actually can be now done in this editor. So based on that, we can, for instance, now select automate the task and create a new element. We can also, of course, create edges, move stuff around, also resize elements and all of that stuff. So whenever you do a change, what actually happens is that the client requests this change as an operation from the server. The server will apply it to the source model, regenerate the graph model, and this will update then the SVG rendering on the client. The same is also true, of course, for undo redo. So when I, for instance, do another change, I can always, of course, undo redo all of these changes. And this will again be essentially done on the server. Also, it supports stuff like label editing. So for instance, I can now edit this label and write something else into it. This label editing also supports certain validation so that are run on the server, like for instance, that the name must not be empty. So the server prohibits confirming here an empty name, for instance, but that's all domain-specific or diagram-specific implementations that you can define on the client. Aside from that, there is the typical editing features that you would expect, so that you can, for instance, select multiple elements and then align them, for instance, left and stuff like that. There is also validation. For instance, if I add a decision node here, I hit a validation button, then the client will request validation item, validation results, and the server sends back validation issue markers, and they will then be rendered on the diagram by the client. They will also be then propagated by the Theia integration to the general Theia problems view, so that you can basically also click on them and navigate between these items back and forth. Also, there is things like auto layout and all this stuff. So everything basically what you would expect. So maybe let's just try auto layout real quick. So now you see that you basically the server relayouted the diagram and sent an update back to the client. Of course, zooming, panning, and all this stuff is supported as well. Right, so that was just a brief overview of what GLSP generically offers and which can then be adapted or which can then be implemented for your particular diagram language. So let's have a look at how this is actually done, this implementation. Of course, there is a client and a server part. Both is structured in a so-called module. It's a dependency injection module for the server and one for the client. Let's have a look at one for the server first. So let me just bring up here, first of all, the Java implementation, where we see that there is a workflow diagram module. So that's basically a module specifically for the workflow diagram language that we've just seen, which essentially then specifies just some ID of the diagram type. Then a diagram configuration, which essentially defines which elements are available in this diagram and also configures them in terms of what you can actually do with those elements. So for instance, whether they are resizable, movable, or deletable and stuff like that. Then it defines a model storage implementation. That's essentially the implementation of where to load and how to save back a source model from some place like EMF or something else. Then a G-model factory, which is essentially then implementing the transformation of this source model into the graph model that we've discussed before, and so on. Aside from that, there is, of course, operation handlers, so what happens when certain operation is applied, and all the other features that we saw, like validation, label editing, and stuff like that. On the client, on the other hand, we have basically the other side of the story. So in the client, let me just find it here. On the client, we mainly need to define how this graph model that the server sends is to be rendered in SVG. And we do that mainly also by providing a diagram module, mainly by these definitions where certain types of nodes or edges are mapped to certain views. So for instance, this merge node, which is the diagram, that diamond shape, is mapped onto a diagram node view. And if you look into the implementation, it's actually a generic default implementation coming from Sprotty. You see that basically this view implements one render method, which gets the node as input and then returns SVG. So of course you can customize that and provide your own view implementation, so you have full control over the actual SVG and CSS that is being produced to show the diagram. All right, so that was the Java-based server and the TypeScript-based client. So let's just the TypeScript-based client in Theia. So let's just do something funny now. We have now here the Java-based server running, and you can see that when I, for instance, here move stuff around, we see those messages here. So let's just kill that server for now. When we go back to the client, it will now say, okay, server died, I can't show anything anymore. But what we will do now is look at the same server implementation based on the node-based framework. So now we are using TypeScript to implement the same workflow diagram language server. Basically, the implementation looks exactly the same. So we define some sort of source model storage, G-model factory, define the operation handlers and stuff like that. And when we now start this server, so now we are have started it here. And when we refresh the client, it will connect to the same server, but this time it will be the Node.js based server, and we see that basically everything works just like before. We can do basically exactly the same thing, and that's really the beauty of this architecture, that you can exchange either parts without affecting any of the other components. So you are kind of future-proof. So if you want to switch some technology in the future, that's no problem at all. The same is, of course, also true for Visual Studio Code integration. So when we look at, back to the slide, we now are still using the one for Theia. So when we now start the Visual Studio Code, real quick, 1 second here. I start the Visual Studio Code instance here, which also has the GLSP editor integrated. So when I open this WF file, then we see here again the same diagram. And now, as you see here, it talks still to the Node.js based server. And of course, we can now even try the other direction. So we close the Node-based server and go back to the Eclipse-based server. Start this again and go back to VS Code. And we started here. Oops. And now it should connect to the Java-based server again. Oh, that took a while. Anyway, now it's there, and we see the same diagram as before. Great. Right. So basically, that was a rough overview of GLSP and the different combinations of technologies that you can use for that. So one thing that I find interesting after a couple of years of developing GLSP and using it in many different customer and open source projects, it's interesting to take a step back and think about what is now the differences and the commonalities between LSP for programming languages and GLSP. And I tried to summarize the differences, especially and why they are there, and especially those that have an impact on the architecture. So first of all, when you think about, of course, the commonalities, client and server, basically the same as in LSP, both communicate usually via JSON RPC within some sort of action protocol. But what's really a main difference between programming languages and diagram languages is the rendering flexibility that you need for diagrams. So while for LSP and programming languages, text is always just text, whether you're developing a Java program or a Rust program, it's always just text, and that will be shown in the editor. For diagrams, if you look at those examples here, they are completely different, right? So it looks different if you the elements look different if you're dealing with a use case diagram or with some sequence functions. Charts. So what's really important is to have here this customizability for the SVG views on the client, which is something that GLSP needs to provide, which is not something that you typically need for LSP-based editors. Also in the same line, it's the editing functionality. So diagrams very often have very constrained diagram-specific editing. So some diagrams allow connecting two types of nodes, but if some property is set, for instance, you can't connect them anymore. You can, for instance, move one node into another node, but not if, I don't know, there is already 3 nodes inside of this other node. So there is a lot of constrained editing. And that's definitely a difference between text and graphical diagrams, because text editing is always the same, of course. So that's, will always, whether it's Java or Rust, you can always enter characters, and that's basically it. In order to account for that, there is 2 or 3 things. On the one hand side, there is this diagram configuration on the server, which specifies which elements can be modified in which way, and which palette items are existing, and so on. And on the other side, and that's very, very important from the observations from the projects I was involved in, is that you have extensible editing tools and UI extensions that you can even add custom controls, because diagrams are by nature very, very specific and domain specific. So they all have very specific ways of how a user interacts with them, which is also why you need to be able to have full power and flexibility to add custom editing tools and UI extensions there. Right, and the last difference, I think, the last main difference is this, what we call sometimes impedance mismatch. That's essentially for programming languages or text files in that sense, the content in the text file is always exactly matching to that what is shown in the editor. And that's great, because think of it, what would happen if you open a text file in a programming language and it would show something different. For diagrams, this is different, of course. For diagrams, there is some sort of source model, and this source model contains the information that is then somehow ending up in a diagram to be shown. So there is some interpretation going on between what is serialized on disk or from a database and what the editors see. And of course, this has a huge impact on the architecture, if you think about it, because we want to keep as much as possible the knowledge about the language, the diagram language on the server. And that means we also need to keep this interpretation on the server. And that means that we have the responsibility to really load the source model, to understand it, to map it towards a diagram graph model, all on the server. And that also means that the manipulation is actually handled only on the server. And that's, of course, different, for instance, for LSP. So how we encapsulate then this whole source model from the client, so that the client doesn't need to understand any of that, is by this graph model that I mentioned before. So if you want to put it like that, the graph model is sort of the common artifact that is shared between the client and the server, And that is also the artifact all other communication is based on. So for instance, the graph model contains some nodes and edges, for instance, and if the user now wants to delete something, the client editor doesn't understand anything about the source models, so it will send a delete node action based on the graph model, and the server, who has, of course, all the information about the mapping between the source model and the graph model it produced, can then actually apply that to the source model and model source and regenerate the graph model. And then, of course, send it back to the client to update it. And that's, I think, a really, really important aspect to have this common generic artifact that can be shared between the client and the server, because that really decouples the client implementation in the diagram from the server implementation and hides a lot of logic there. So it's a little bit like LSP, where LSP, the language server protocol, also doesn't expose any intrinsics of the language. It just communicates based on text files, lines, and characters, essentially. And that's corresponding to the graph model in GLSP. Right. So as I mentioned before, I think this is all, you can summarize these differences, that diagram editors are specific by nature. And this is why GLSP is built for customization and really open for extensions in all sorts. So it uses dependency injection so that you can even change all default implementations easily. And what is even more important, it puts no abstraction layers on top of any of the underlying technologies like SVG or CSS or EMF if you use that on the server and so on, or whether it's JSON. So basically you're dealing with that yourself. The framework supports you in that, but it doesn't put any abstraction layer on top. So you have the full power of the underlying technologies and the flexibility to choose what parts of that you will use. And you can even very easily add a custom client editing tools, feedbacks, additional controls, and stuff like that. So just a real quick demo how this could look like. If I go back here to the Theia editor, I think I started the Java server now in the backend. Yeah, it still runs, doesn't matter which server it is. So you can, for instance, here add custom actions that perform some modification on the G model, for instance, to highlight the path. So the server will actually compute the path and will just send down some CSS class assignments to elements, which are then can be arbitrarily rendered, of course, on the client to really take advantage of the nice features that SVG and CSS provide without any additional knowledge about anything else. You can just implement that without a lot of work. The same is also true. You can extend the UI to add custom controls to your editor by just adding so-called UI extensions, which would then can render arbitrary HTML on top of your diagram. Essentially, the palette is also done with the same mechanism. And here I now enable the custom additional control. And with that control, you, for instance, then trigger an action that will send to the server that we want to show only decisions. And the server would then take the source model again, regenerate the graph model in a little bit different way, set the edit mode to false so that it's only read-only, and would update the client. And with that, for instance, you can switch back and forth between two different views, whereas this view is really edit read-only, so you can't really move something. You can just pan around, zoom in, zoom out, and it would filter out everything else. And when you switch back, the edit mode is just the same way there again. So you can do such really domain-specific things quite easily, and I think that's very important. Another great advantage of, I think, this no abstraction layers is that you can take advantage of all the outstanding debugging tools that actually exist. So there is nothing in between, for instance, your view implementation that I just shown you before. So when we just go back here 1 second again, we see that we directly output SVG, and that's exactly the same SVG that when you switch into the debug, the dev tools of Chrome, that's exactly the same SVG that you would, for instance, if I try to increase the size here a little bit, that you would also see here, and then you can very easily, for instance, change certain properties in CSS and see how they affect your diagram. So that's a very smooth development experience, I think. Right. And with that, I think I covered most of what I wanted to mention. Yeah, in conclusion, maybe just to summarize really quick, I think in GLSP kind of provides the benefits of the language server protocol, which is the modularity in a sense, and the flexibility for customization by not introducing any abstractions and giving you full freedom to edit, develop your specific editing tools and custom controls. But what I think is even more important is the modularity and choice, especially in a volatile technological ecosystem like the web-based one. It's important that you can choose between VS Code and Theia, Java or Node.js, whether it's EMF or JSON on the model, and then not only have the choice, but in the future change any of those decisions without impacting any of the other technologies or components that you're using. So for instance, if you switch from, we want to now start with EMF, but switch later on to JSON, there is not much to change in the server in most parts and nothing to change in the client and nothing to change in the client platform integration. So that's really, I think, something very important to consider. All right, with that, thank you very much for participating. I really invite you to try out GLSP for your specific use case and get in contact with us if you have any issues or want to discuss your use cases. With that, thanks again, and I'm really looking forward to answering your questions.